Among a random sample of 450 adults over age 25 living in the USA, 138 of them had a 4-year degree or higher. Use the results of the sample to construct a 95% confidence interval for the true proportion of adults living in the USA with a 4-year degree or higher. A friend of yours claims that in the USA, only 20% of the public has a 4-year degree. Does the interval contradict your friend's claim? All right, so in this problem, they're asking us to construct a 95% confidence interval for the true proportion. So it's important that you read the whole sentence when you're looking at these problems. If I just saw a confidence interval and I tried to apply the confidence interval formula for the mean, obviously I would be going wrong. One way to kind of pick up on you're using the wrong formula in that case is to notice that there's no standard deviation given in these problems. And because you're missing a standard deviation, that'll kind of be a clue that, oh, I'm probably using the wrong formula. And then if you read the problem more carefully, you'll probably be able to see that it's a problem about the proportion. Okay, so the first step in all confidence interval problems is to record the data. So I'm just going to copy down some items that we're going to need. So we'll need a sample size. Now we used to need a sample mean and a sample standard deviation. Instead of that, we're going to have a sample proportion p hat, and then we can do 1 minus p hat. You can call that q hat as well. And then from there, you'll need the normal confidence level and alpha. Okay, so the n in this problem is 450 because they sampled 450 adults. Now for p hat, they don't give you an actual sample proportion. They give you the numbers that you need to construct a sample proportion. So remember, that's x over n. And we want to remember that x here represents the number of subjects in your study that had the trait you're looking for. In this case, the number of subjects with a 4-year degree. And it says that that number is 138. And then, of course, we already found n to be 450. All right, let's work that out as a decimal. So we'll do 138 divided by 450. And it gives you 0.3067 approximately. So I'm going to go for 0.3067. 0.3067. I recommend you use 4 decimal places. You certainly should not use less than 3. Okay, so if you're going to round it off at some point, you can store it in your calculator and use the whole value, and I actually recommend you do that. But if you don't do that, then I recommend that you use at least 4 decimal places. Okay, and then you need to do 1 minus that value to get the q hat value, and all you have to do then in your calculator is 1 minus the value you already have. You'll get your solution, which is 0.693 repeating, so I'm going to call it 0.6933. So this is approximately 0.6933. Okay, then you'll need a confidence level. It said we had 95% confidence, or we want 95% confidence, so 0.95, and that of course makes alpha 0.05, taking 95% from 100%. Okay, so you have your data. Now we're going to get our critical table value. In these problems, we will always use a z critical value, so it'll be z alpha divided by 2. That's going to be z half of alpha here. If alpha is 5%, will be 0.025. That's just to fill in the notation. And then we'll look this value up on our chart. Okay, so here we are at our t-table, and we can look up either that 0.025 value, that half of alpha value, or on this table that I use in my classes, I have 95% labeled at the bottom, and that's where you'll find your critical z value, and you'll find that the answer is 1.96. So 1.96 is your critical z value. Now that you have your data and your critical value, you're going to do your margin of error. Okay, and your margin of error formula here is a little different than it used to be. So we'll have z alpha divided by 2 times the square root of p hat times 1 minus p hat all over n. And again, that 1 minus p hat can be called q hat as well. So z alpha divided by 2 is 1.96 times the square root of, you'll just fill in the values you calculated before, so 0.3067 for p hat, and then 0.6933 for your q hat, and then divide by your 450, which is your sample size in this problem. When you enter this in the calculator, you don't want to do anything special here. You just want to go ahead and put it in as you see it. So 1.96, and then the square root of, and then don't put special parentheses here. Just do 0.3067 times 0.6933, and then divide that by 450. Close up your parenthesis, press enter, and you'll get your answer. So our margin of error is about 4%, so 0.0426. 0.0426. So that's your E. And once you have your E, you're going to use that in the final step of the process. So the last step is to fill in the formula by doing p hat plus or minus the error, right? And we'll actually do the subtraction part first. So it'll be p hat, which is 0.3067 minus 0.0426. And then we'll have 0.3067 plus 0.0426. Okay, and let's see what that ultimately gives us as our answer. So I'm just going to store this value, our error, as x just to have it, and I can just type it in then easier. So 0.3067 minus that error that I stored, and then I'll do the same calculation, but this time I'll add. So 0.264 to 0.349. So I'm actually going to write this answer up at the top here. So 0.264 up to 0.349. And that's where we think the true proportion lies. So we'd say that normal statement that we're 95% confident that the true proportion is within this interval. And then the final thing I want to do here is I want to go ahead and say, what do we think about the person's claim in the problem, right? So it said a friend of yours claimed that only 20% of the public in the United States has a 4-year degree. But our interval says the true proportion, P here, we think the true proportion is somewhere between 26.4 and 34.9, or approximately from 26% to 35% of people. So we think somewhere in that range is the percent of people in the United States that have a 4-year degree. So it doesn't seem like it's as low as 20%. So this friend of yours that said it's only 20% doesn't seem like he's correct, because the percentages here seem to range from 26 to 35% approximately. So it's somewhere within that interval. And our sample proportion, by the way, was close to 31%. So it appears that it's probably higher than 20%. So yes, the interval does contradict your friend's claim.